The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Welcome back to David Mickle's Shiny Side Up, show number 490, 90 and 400. We're going to talk about UFOs, UAPs as they're called now, the logical, rational approach. We spend a lot of time talking about it, the size of the universe, etc., how unlikely it is for alien beings, extraterrestrials, to be anything like us. If they truly developed on another planet and looking at the number of planets, just and galaxies and suns, etc. I mean, it's uncountable. It's massive, and in that vastness, to come across creatures that are just like us or very similar to us in any which way, in my opinion, is extremely unlikely. Unless there's a seeding event. Unless we really don't understand how this universe works at all, which again I think we don't. So what does it leave us with then? All these activities that we witness, and they are now officially acknowledged. They can't call it UFO disclosure. It's a UAP admission, unidentified aerial phenomena. No longer unidentified flying objects. No, because that's really too loaded a phrase, and we can't acknowledge that those exist. So they're called UAPs now. They're real. I don't care who you are, which rock you've lived under, UAPs are real. They're not swamp gas, they're not low-flying geese, they're not Venus, they're not the moon, they're not none of that. We don't know what they are. That's the official acknowledgement. It's a fact. It's a thing. And it is really important to understand that. It is no longer, Dave, it's no longer a point of discussion or contention. We're no longer discussing it. This is real. That discussion is now dead. Mm-hmm. It is real. The phenomenon is real. It's a thing. And do yourselves a favor. Watch the Secret of the Skinwalker Ranch, season 1 and season 2. Season 2 is out now as well. Secrets of Skinwalker Ranch. And there's a guy in there. He's been showing up in a few things, and he sort of triggered my epiphany I had around the Masons as well. But my point is that you need to now. You no longer have to defend yourself or your opinion if you believe in this phenomenon. You don't, because it's acknowledged. That is not. Now we can discuss it as to what it might be. What might it be? Okay, we'll find out. We'll discuss it. But now we can discuss it. But the thing is this. So Dave and I have been looking at this for a long time, and Dave himself, I don't want to speak for him, but he's an experiencer, right? Dave has experienced things, right? Mm-hmm. Strange things. He's been told he's wrong about that, which I find, it's like you're driving on the highway, and someone comes the other way and goes, "You're going the wrong way." How would they know we're going the wrong way? They don't know where we're going. What? You don't know where I'm going. You're the wrong way. Oh, okay, then. Thanks, buddy.
No, just let me say that I wrote that in a book, saying I was driving down a road, and because that was my experience, and then they told me I was wrong. That's how ludicrous it was.
Yeah. Okay. Now, isn't that look?
Hi, Mace 139.
Yeah. It is not a thing. Yeah. Hi, Mace, and hi, Acid. Good to see you in the chat, mate. It is really incredible. So we can now have a discussion as to what it might be. Now the real work begins, right? So what I see though is this. I see a lot of phenomena that are completely nonsensical for extraterrestrials to undertake to the length they're undertaking for. Cow mutilations or cattle mutilations, abductions, alleged interbreeding, hybrid creations between humans and alleged extraterrestrials, etc. Something completely impossible. Never mind aliens that developed on another planet independently of us, but on our own planet, right? And the only reason we know that we are cohabiting the world with Neanderthal and Denisovan man, etc., is because we interbred and we had children. So that means we are not a different species. We are the same. We are human beings, full stop. And I said this before, and I said it again, it's my favorite example. Horses and donkeys can breed together, but they can't produce fertile offspring. They cannot. They cannot. Now, what would happen if an alien being with a completely different biochemistry to us came to this planet, probably needs a suit to walk around in the first place, and then tries to interbreed with us? It just wouldn't happen. Now, could genetically could it be that maybe they have genes, maybe they have DNA, maybe they do, maybe they have RNA, maybe not. But let's say they do, right? Then with advanced genetic knowledge, I'm sure something could be done. But breeding, like physical intercourse, is completely out of the question. Makes no sense whatsoever.
Okay, so their blood. We know on Earth, right, that chimpanzees, being, was it 98.3% similar DNA?
Yeah, very close. Yeah,
we can't interbreed with them.
Nope.
Right. So just saying that if an alien species was, like they were of another star system, the likelihood of interbreeding would be 0. That's just the way that is. Don't think it could happen. They might have, just for the matter of fact, you go and visit some other, planetary system. Doesn't matter, even if it's Mars. This is this preposterous idea of taking people and living there. We don't know what microbes are there. That's all, right? They've kind of said microbes exist there, but if it was completely sterile, great, woohoo, new planet. But if it isn't, and there has been life there before, we won't have had any exposure to them or any of the things there. And it could, like every person we send there, we won't know for months, right? They're on inbound. They get there and, they decide, I'm gonna breathe the air, right? And that's the end of that. They traipse some dirt in, Mickey, and it warms up and the microbes are free. Right?
Why is your face melting, Dave?
I don't know. But it was the start at the time. So this is Becky's point is valid here. And unless you are a genetic match, then it's not going to happen. Unless, of course, Becky, when they say making love and producing offspring, maybe it was only because they DNA spliced stuff together.
Look, we don't know, right? But the more likely scenario is they're already here, and they've been here all along.
Yeah.
They're an inner Earth civilization, they're an inner Moon civilization, inner Mars civilization. I don't
under the
care.
ocean, whatever, right? Mm-hmm.
Or potentially out of space, or in another dimension, or, and this is really interesting as well because we've spoken. We'll talk about this again. Maybe from another timeline as well, from a point in time that is not our point in time. And why do I say this? Because the technology that these beings seem to deploy or employ in their endeavors hasn't changed in thousands of years. In thousands of years, the tech hasn't changed from what we can see. All the reports, like what these craft look like, blah blah blah. It's always the same. Mm-hmm. And even the description of the beings themselves. Now, a civilization could be static. It could be a static civilization. It is advanced, and then it sort of entered a decline potentially, or they've reached a certain pinnacle. They can't go any further. They've reached the pinnacle of what can be achieved. That's possible. Or they're all coming to us from a point in time. They're coming from. I'm just making stuff up, but they're coming from the year 5000. So all the visitations we've seen over the last thousands of years, they came from the same point in time, right? And that doesn't make sense. And they're here, or they're already here. They're living underground, under the ocean, etc. Because it makes no sense at all to continuously dissect cattle, to continuously abduct humans and perform experiments, to try to interbreed, etc., and all of these strange phenomena that we're witnessing, especially on places like the Skinwalker Ranch, the Bermuda Triangle, others as well. I mean, famous plane disappearances here in Australia, of course, as well. It just doesn't make any sense. It makes no sense whatsoever. I mean, colonize us already. I mean, what's stopping you? Clearly, you can do whatever you want, right?
Yeah, that's right. They can come and go at will, and anything they do, we can't have any control over, right?
No,
so,
none.
and not militarily, not willfully, nothing. The only person it did was Phil Snyder.
Yeah, well, yeah. Good point, actually.
He shot some, right?
Yes, yes.
It was with the loss of his fingers, right? And an SAS guy that died.
Yeah. No, that's a very good point. Look, there's actually something very interesting I want to share with you, and this comes from the Skinwalker Ranch TV show, which again I urge you do watch it. There's this iPhone. There's a security guard, and he's a security guard on the Skinwalker Ranch, right? He's just working there, and the scientists all around him, they're trying to dig up something. And his iPhone, which is locked and secured with a password, unlocks itself. And then somebody goes through the apps, through his contacts, etc., on camera. He says, and the scientist, the chief scientist, or one of the chief scientists there, he's an astrophysicist, and his name escapes me. I do apologize. That's actually not possible. In fact, he said, because he does work for. He's the guy that analyzed the Tic Tac video for the Navy. That's the guy. He's also showed up on Oak Island, interestingly enough. And he must be, in my opinion, he's a Mason, but that's neither here nor there. He goes, the NSA couldn't do this. The NSA couldn't remote hack your phone, unlock it and break the encryption. But whichever entity or whoever is on the Skinwalker Ranch did it. They did it on camera, and he couldn't control the phone. It was so fast. The screen was going through so many different things. It was quite something to see there. Now, do you take everything with a grain of salt? Of course you should. But there's some things which are just coming together right now. This is the time. I don't know why, Dave. Maybe we've reached a certain level of, advancement, scientific, maybe intellectually. Who knows? Maybe our numbers are not high enough, as we hypothesized, with the Ascension event at 7.76 billion. Maybe there are other things. Maybe we're entering a certain quadrant of the galaxy that has special radiation. I mean, I really don't know what is what, but we are seeing things accelerating significantly. And this is all around us. I don't know if you guys have that feeling as well. And this goes to you, Dave, obviously. Do you feel that we are going through an accelerated experience here? Like things are just happening constantly. This is no longer any respite. It just happens. Bang, 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 bang.
Yeah, it's like a play schedule. Is going on right now. Since 2012, there's a lot of people been referring to this as the quickening.
Yes.
And I have to say it's kind of a thing. To be honest, since 2001, where life pre-2001, say, let's just pick it June 2001. Times are good. Life was great.
I know, right?
Yep. We were all optimistic. The world was our oyster. Nothing mattered. It's all good. Where we are now is it's a cascade of changes that not just parallel ones, but one after another, where you couldn't do today's one if you haven't done the last one, right? So like a waterfall effect. And I'm astounded that we've not fought against any of this stuff. No one has spoken up against it, Meki.
Yeah, because we have been. Okay, so this is interesting. The 60s, the 70s, even the 80s, but that's when it started. But the 60s and 70s, and in fact in the 40s and 50s, people wouldn't have stood for it. But we have been educated into complete mindlessness. So you know what the biggest problem is with people in the military? They can't get people easily to kill people. It's not like people don't like to kill people. That's a real problem for the military, right? And when you go to war, not having people, and they're disappointed, I'll come to it, having people not wanting to kill people, it's a massive issue. So you do whatever you can to break down that person and make them into the killing machine that you need, right? But by the time that you get to them, 18, 19, whatever the conscription age is, it's too late, right? Some you can change, and they're weak enough and all that. But most people, you still have that issue. So what you need is you have to get to the children. Get to the children before they can even walk. And we've done this, Dave. That's exactly what we've done over the last few decades. We have gotten to our children. And look, I've played video games with the best of them, right? I love video games. But it was part of the program. And also violence on TV, violence in the media. If it bleeds, it leads. That's actually something they say in the media world. If it bleeds, it leads. Our children are exposed to more carnage than any other generation before, right? And that's people that have lived through wars. And I mean, I'm talking about the visual and auditory stimulation when it comes to carnage. Nobody has. So we've created that kind of desensitization. But what we've also done at the same time, we have dialed down on actual education, teaching people how to think. I told you this before. The German army had a huge issue. Couldn't win a war against Napoleon. Can't be the guy. Why? Because the Germans were thinking too much. They were philosophers and they liked history. They had a really good educational system. So the Prussians said, you know what? We're going to standardize education. Let's do that. Like rote learning, right? And we're just going to create all these cut-out cardboard soldiers for army, and it worked. It worked. The Prussians became the most efficient army in Europe at the time. Okay, they just changed the educational system for the children, and Hitler knew this. Hitler Youth, the communists know it. Every totalitarian dictator, fascist, whatever, they all know this. You have to get to the children. If you get to the children, you can give them their belief system. Not only that, you educate them in the way that you want them to. On top of that, let's give them a really bad diet. Let's give them food that gives them behavioral problems. Near food. Near food experiences, right? And we know this is true as well because Morgan Spurlock went to a school in America that took in all of the troubled kids from other schools. So if you were kicked out of every other school, this is the school you go to, right? We're talking about teenagers, right? Young preteens and teenagers. And Morgan Spurlock looks around, geez, these kids look normal kids. They're not hyperactive. They're not running amok. And the principal said, yeah, we're feeding them natural food. So then there were no soda machines. There was no snack machines on the campus. They didn't get any processed food, any processed sugars, any processed starches, nothing. They were cooked healthy meals. Do you know how many gun crimes existed in America prior to the 1950s or even 1960s? I mean, I'm talking about mass shootings here, right? People actually going out there and shooting people. Hardly any. None. Yeah. Kids used to take guns to school in Australia as well. This is something we educated our children into. We desensitized them to violence. We fed them near food, zombie food, Frankenstein food that made their bodies and minds. We damaged their bodies and minds. We did this. Now, not every child will react to this kind of punishment the same way. It's only a few that really break and push beyond the limit. But if you add a few other factors, then you can push them even further. I know somebody very, very close to me, years ago, that took drugs one night, only one night of drug taking, and he never came back. He in fact killed somebody. Because he had become psychotic. The one drug experience turned this person. This is an extreme case, but my point is that we're doing the same thing to our children. Now we don't turn all our children into psychotics. We do not. But we are introducing the spectrum diseases. We have introduced them. The allergies. We've introduced the autism spectrum diseases to our children. We've introduced the uncontrollable violence and rage disease in our children. And when I say this is a plan as well. It's a plan. What kind of food did our grandparents eat? Organic. Why? Because that's the only food there was. There's nothing else. There's no other food. That's all they ate. Real food. Real food.
Actual food, yeah.
Right? Sorry, I don't want to go on too much about this, but it's really important to understand where we are here. So I think these aliens or extraterrestrials, et cetera, they're here. they don't really. I don't think they care too much about us. I mean, we've got nuclear power now, so they're probably interested in that. Spaceflight probably interested in that. Are we at all interfering with them? Why didn't we go back to the moon for 50 years? 50 years. We went to the moon, and a few times the astronauts that went there, they slip up. They let something out. You got to listen, though. You got to listen. Be careful. I've gone into some detail there. They let something slip. We found something on the moon, and that's why we didn't go back for 50 years. Because I think, Dave, and I know you're the same, we were told, hey, you guys better don't come back for 50 years. Okay? And we didn't. 50 years! We've been driving trucks in lower Earth orbit, right?
Yep.
For 40 years. The whole space shuttle program. This was driving trucks into low Earth orbit. Oh, you can have a space station. Yeah, sure, it doesn't matter. No, okay, don't come to the moon. Don't come to the moon. Don't come to Mars either. In fact, only a few Mars missions actually made it through. You know that?
Yeah.
Voyager, Viking. I think Voyager, maybe Viking. I can't remember. Was the first that made it through and gave us the pictures of Mars. A lot of them crashed, destroyed.
And one of the Russian one looks like it was taken out by something.
Yeah, it disappeared. Gone. Anyway, so I think they're here. They don't care too much about us. They should, because I believe they had a hand in our presence here. But ultimately, a colonial power, once it leaves the colony, they don't really care too much. I mean, all we would be unwelcome. Imagine, so the British Empire, right? Even the French, they colonized all the world. Now they have to take in the people that they had colonized because they're part of that empire or part of that Commonwealth. Not something that the French and the British are too happy about. I can tell you that. But nonetheless, so maybe our erstwhile imperial overlords feel the same way, if that's what they were. But there's one thing here though, and we didn't get to finish last week, and I want Dave to take this because it's Dave's baby, and it's important. It's important. The universe. The size of it, light, etc. It all comes into us understanding the universe. It fits thematically very well with our show. Please, my friend, take it away.
Oh, I thought I'd covered it off enough, though.
Oh, if you're happy with it, but then
I'm happy. I'm happy where it went. I'll just take it from Science Explained.
Perfect. But also add your commentary to the discourse, because that's the official story that we're sharing with you now.
Yeah. So, in one sentence, the universe isn't forever expanding. Doppler effect is not what it is that's causing the redshift to make people believe the universe is expanding. And the further away you look, the faster it's expanding, because it's entirely preposterous. If everything's expanding away ever faster the further it is, that means we're at the center again. That would mean we're at the center. And if you're at the far edge that we can see, and everything is expanding away faster and faster the further it is away, then it doesn't make any sense. And it doesn't make any sense because light diminishes in wavelength over time, and that's what we're seeing as evidence, and I've made that kind of clear now. All right, so that's really all it is. And I approached a physics professor at one of the universities in the US, who was my physics professor while I was over there, and he said, just prove it. Don't care. You can be right or wrong. I said, because I'm a scientist. I don't care. Just prove it. And every time I hear, Maggie, every time I watch something where someone's talking about the expansion of the universe, I do a face palm now, because I can just see how wrong they are. They believe what they're saying, and that's fine, because at least they're carrying a narrative. But they'll never be able to think outside the box, because they're carrying the narrative. And they've told you remember that theme, Mackie, it doesn't matter whatever's going on, as long as they name it, you can just put it aside.
That's
Placebo effect. No one's researching it. Yeah, don't worry about it. Move on. 56% of people in the placebo effect research that we looked at got better on their own, just because they willed themselves better by thinking they had the right medicine. Anyway.
Yeah, I know, but no, it's Dave.
But we named it.
It's a placebo effect.
That's right.
Understand?
Yeah. Oh, I understand. We named it. We can I'll just put it aside. Get back to the research. Yes. Continue the research. Okay, so all right, science explained. How can the diameter of the universe exceed its age? And this is one that gives them grief because the Doppler effect, right? But I'll continue. I'm just going to read it the way the article is written. This is why our universe's size isn't limited by the speed of light. The size of the universe. The speed of light is one of the most important fundamental properties of our universe. It is used to measure distances for interplanetary communications and in various mathematical calculations, and that's just the start of it. The speed at which light travels through a vacuum is just less than 300,000 kilometers per second, or if you like the other, just over 186,000 miles per second, is static and unchanging. It doesn't change speed. If you remove that constant, the very foundation of modern physics crumbles due to a number of reasons, and the general rule can be summed up with this: nothing in the universe can travel faster than the speed of light. Actually, that's kind of preposterous as well. As you can imagine, some confusion arises when one considers the fact, I love how they use fact, Mickey, that the universe is not 13.8 billion light years across, a number that corresponds with the age of the universe. In fact, that's not even correct at all. So we can see about 14.6 billion light years away from us with the naked eye, and it's 50-something billion years to the radio wave extension of it. Never mind. In all directions, meaning it's 100 billion something that we can actually detect, not see. By current estimates, says the article, it's actually quite a bit larger, with the estimated diameter of some 93 billion light years. See, I was pretty close, 100. And that's just what we can see. What we can't see may go on forever. So, how can the universe be 93 billion light years wide if it's only 13.8 billion years old? And nothing can travel faster than light. Well, we have to ignore the fact that there's a couple of stars that are older than 13.8 billion years, and that was just a rough guesstimate. And the scientist who came up with that keeps getting bandied around. These numbers are stupid numbers and blah, 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 right? So I've gone way past the extent of the intelligence of the person writing this article. Understanding redshift. Here we go. Before you can understand why the universe's size is so much greater than its age, it is important to understand just how light works. Sir Isaac Newton was unquestionably I'm just going to put that on the screen, one of the greatest minds ever to live. So was Einstein. In addition to inventing calculus, he was the first scientist to truly understand the essence of light and what happens when you break it into its constituent parts. For starters, his research revealed that black is the absence of color, while white light, like that which comes from the sun and other stars, actually our star's quite yellowish, is a combination of every color. By looking at an object's light through a prism, one can see the corresponding elements the light represents, which can then be used to help determine the object's composition, temperature, and even where it is in the evolutionary process. In fact, Meki, this prism example is incorrect because red bends more than violet.
Correct. Well, we're looking at a little graphic here.
I've got it on the YouTube clip, right? It's a bit similar to Pink Floyd's album cover.
Yeah, that's it. That's good. That's a good description.
However, when you look at, you'll see the same thing. When you look at a rainbow, the violet's on the inside because it bends the least. All right. In more ways than one, back to the article, Newton's work revolutionized physics. It did. and paved the way for all of the greats, including Niels Bohr, Max Planck, and of course Albert Einstein. For the purposes of this discussion, however, the most relevant scientist to build off Newton's work went by the name of Christian Doppler. Now I'm going to start throwing up into the back of my mouth in a minute. And Doppler came to prominence hundreds of years after Newton's death, and if you aren't familiar with his work, he discovered something that is now called the Doppler effect. This process explains why some light from cosmic sources tends to land near the red end of the electromagnetic spectrum, while some light is closer to the blue end. Now, look, I'm not going to dispute the Doppler effect for audio in our medium. That's fine. It's good. Yeah, let's leave it at that. But for light, and why is everything the further away it is redshifted into radio frequencies? That's a big question that I can answer. But the only explanation is by making up another thing that's happening. It just does my head in. It's like dark energy and dark matter. Yeah, let's just make that up. Or Einstein's constant. Yeah, let's get the equation so wrong and smash our heads to make it constant to make it work.
And let's ignore what experimental physics or reality actually shows us, like the quantum entanglement, things like that. Oh no, it can't be real spooky.
It's spooky action and distance. So it clearly showed Einstein's limitations, right? He was a math guy. If you can't prove it with math, then it doesn't exist, right?
Right.
And that same explanation was...
That's why Tesla had such a huge issue with him.
Oh, he did? Yeah, that's where I was going. Yeah.
Well, no, keep going. Yeah.
No. So yeah, Tesla said, these people who don't actually do real experiments, they're just mathematicians.
Bingo.
Yeah. And he said, the things that I'm working on, it just doesn't work with.
Yeah.
Right. So yeah, good luck with that. You'll never find anything new, says Tesla. This process explains why some light from cosmic sources tends to land near the red end of the electro or the EM spectrum, while some light is closer to the blue end. In simple terms, the Doppler effect notes how the wavelength of light is shifted based on the direction that the light source is moving, like whether something is coming towards us or moving away. Specifically, light waves will be stretched if the light source is moving away from the observer, thus appearing red, and conversely blue if it's coming towards us. However, remember that had to be created, that thought, while we haven't actually proved it, except for looking through a telescope into space, we haven't provided that same proof on a desktop lab environment. We just haven't, because light doesn't change enough for anyone to see. Plus, it's still too new to... it's like the speed of light. We actually haven't measured the speed of light. Did you know that? We actually haven't physically measured it, which is really interesting. We've guesstimated it, and we like it, and we've seen what it means when we have like a Viking or Voyager out in space, where we can tell how long it took the signal to get to us. We can tell. And we know that we can do that through stereoscopy of the planets from side to side in our orbit. We know how far away they are. So we've determined it that way, but actually measuring it like you measure a runner on a track, no, we haven't done it. And if you see those, also, if you see the video the information about filming the speed of light, that's also incorrect. With their, 1 billion frames a second cameras, they're still not able to watch light moves. What they've done is taken, 1,000 different images showing at a single point in time and put them together, all randomly taken, to be able to show the progression of light, though it's not a single camera with a single shot turning it on like the squirrel from over the hedge when he has the caffeine. We're not seeing that absolutely. But I want the cookie. When the lasers are slowly advancing after being turned on and he can evade them, we're not actually watching that with those 1 million frames a second cameras. what they've actually done is basically faked it. They've faked watching the speed of light. Anyway, so the expansion of the universe. Here's where things get sticky. Our observations, this is physics, not me, not my belief, of redshift reveals that objects 3 times more distance are moving 3 times faster relative to nearby galaxies. That's also preposterous. They had to make it up. They had to explain what they were seeing,
So
and then
you have to fit facts into your theory, man. That's
yeah, to make it work. That's right. Well, mine doesn't need any of that.
Give me that hammer. What are you doing?
I don't have to have these stupid things in there to make mine work. The farther we look into space, the faster galaxies are moving. That's because of the redshift. It increases. In fact, it increases all the way through microwaves, through redshift to microwaves to radio waves. And they still think that's going faster. Right? So fast at these vast distances that they easily surpass the speed of light. However, but that doesn't work, right? So, however, as previously stated, the speed of light is the universal speed limit, apparently. Just like the speed of sound, Mickey. Oh, and trains that did 28 miles an hour, where everyone would,
Skin
suffocate.
will be ripped from your body.
I go pirate when I go Scottish. So how can all of this stupid postulation have come about? First, note that while there is a limit to what we can see, the actual universe extends much farther than we can comprehend. Everything within this limit is called the observable universe, and it includes 10 million superclusters, 25 billion galaxy groups, 300 billion large galaxies, and 7 trillion dwarf galaxies. 30 billion trillion stars.
That's a lot of stars.
Hey, that's a lot of stars.
I can't drink that much coffee.
All of this was tucked into 13.7 billion light years of space-time. The universe would be, in fact, it would be all squashed together. It would just be a lump of solid universe. That's what it would be like. But that's not true. It isn't like that at all. So the first problem with the assumption that the universe's size should be equal to its age in years based on the distance light travels arrives when we look at the first few moments that, here we go with the Big Bang. So the Big Bang was theorized because everywhere we looked, there was 3K microwave radiation everywhere, in every direction, every single direction we looked. There's this background radiation. Remember, if you go from
it's the afterglow.
Yeah. Right. So visible light to infrared to microwave background radiation. Then further beyond that, we see stuff in radio. Right. So they called it the temperature of space from the Big Bang. When the first universe popped into existence, approximately 13.7, I just vomited it in my mouth again, billion years ago, space-time itself began expanding at speeds faster than the speed of light. Preposterous again. This period, called inflation, is integral in explaining much more than the universe's size. It also covers things like the homogeneous nature of space on a large scale and the conditions that existed during the first epoch. These are all made up. Every single one of those phrases are made up. Basically, the universe...
I'll throw words at you. I'll just throw lots of words at you.
Yeah, precisely. So once again, the Big Bang was only put in place because of the redshift that they saw, and they had to explain, well, if it's all flying away from each other, it must have all been in one singularity at one point and then exploded. That's it. That's the only... And if redshift doesn't mean that the universe blew up from a single singularity, right? If redshift is that the light ages, then it's not doing any of this stuff at all. So the Big Bang doesn't have to get made up. The universe ever expanding and speeding away from us doesn't have to get made up. It's just simply light ages, right? Anyway, basically, the universe transitioned from an infinitely dense and hot state into a vast area teeming with protons and neurons. Oh, neutrons, sorry, not neurons. They're brain cells. And particles that eventually came together and forged the building blocks of all matter within moments. Within moments. Like 100,000 years and we had stuff going on already. Now, after the initial inflation died down, the expansion slowed. Now objects are being pulled apart by the mysterious force called dark energy. Oh. See, there you go. So there's 4 separate things they had to make up to make that work. Sorry, man.
Mysterious force.
That's why I just... but look, it is a passion of mine. I really do appreciate the time on it.
But people have come to go off dark energy and dark matter. So let me just intercede 1 second here.
Hey, it's all yours.
So gravity is an extremely weak force compared to electromagnetic force, for example, or the small, large nuclear forces, right?
Mm-hmm.
Very small, very tiny, and powerful. I mean, right? And you can test it every day by having a magnet picking up a nail. When you do that, you're acting directly in contravention of gravity. Okay, every time you do that.
Mm.
But you don't even need a powerful magnet, just a regular magnet. Anyway, so in order to explain that, they go, well, a lot of the gravity has to be somewhere else. Or, and I love this, there is something else that explains the expansion of the universe. Because we can't really explain the continued expansion and the weakness of gravity other than by introducing something called dark energy. Well, if you got dark energy, then it must come from somewhere, and that's dark matter. Now, apparently, and this is interesting, there isn't enough matter in the universe for all the things to work as they do. There just isn't. In fact, to the tune of 98%. So 98% of the universe is made up by dark matter. All right. So out there in the universe, someone is looking around wondering where the missing 2% is. Right? That's really what this is. So we've got a cosmology based on a 98% unknowability. Might as well talk about God. God is ineffable. Dark matter is ineffable. And that's the end of the discussion. We don't know we haven't seen dark matter. We don't know what it looks like. We don't know where it is. All we know is that our cosmology, our models don't make sense unless we introduce both dark energy and dark matter. Hopefully that cleared it up a bit. Sorry, Dave, go on.
Go on. Fasten light through means that haven't yet been ascertained. This expansion, see, once again, we can't explain it. We don't know what's going on, and we haven't quite worked it out. This expansion does not appear to be happening faster than the speed of light, but that doesn't mean that you probably think it does. I'm afraid the confusion stems... I had to pause then for a minute. The confusion stems from the basic misinterpretation of relativity itself, which I don't misinterpret. You see, the theory states that objects cannot travel faster than the speed of light through space-time. It doesn't, however, place any limits on space-time itself. So what they're about to say is the expansion of the universe doesn't break any rules because the universe itself is expanding and things aren't actually moving at all. I bet that's what it says. So to summarize, the size of space does not conflict with the basic physics. Essentially, galaxies themselves and any other objects in space aren't breaking any laws because they aren't traveling through space faster than light. At least, not in the traditional sense. Rather, every portion of space is expanding and stretching. It's not even that the edges are flying outward, but that space-time itself, the area between galaxies, stars, planets, you and I, is stretching. In short, space-time is expanding and pushing matter apart. Matter is not really traveling through space-time.
So what has happened here now is we have reintroduced the ether into our world, which is fine. I got no issue with that, right?
So space-time itself now is a force.
So it's actually a thing. It's not a force. It's a thing because it expands. So it's hard to explain, but this way. Think of the universe. Think of space-time as a balloon, and the universe is like the galaxies and stars and all the space in between, that's at the skin of the balloon, right? So space-time is the balloon, but the universe itself, like the stars, the space between the stars and the planets, that's all the skin of the balloon. So as you blow up, this is what they're saying, as you blow up the balloon, it appears as though that these planets are racing away from each other. They're not. It is just that the balloon is expanding, which is space-time. So that's what they're saying here. Space-time is the balloon. Now, the funny thing is this, right? So it's an underlying manifestation of material that can push things apart. That's what it is. That's the ether. That's the quantum form of our existence. Is it true? I don't know, and I don't care because it doesn't matter, right? What matters is that we have completely misunderstood the nature of the universe and our place in it. We don't understand how the universe works at all. We've made up a whole bunch of stuff. We need, in order to, this is the funny thing, in order to explain the universe, we had to say that 98% of the universe we don't really see. We can't see it, don't know where it is, don't know what it does, and shut up. Essentially.
Oh, I love this shut up defense.
Because what Dave has just gone through here, in my mind, is so much double Dutch. Because the thing is, there's so many suppositions and assumptions in the little text that Dave has just shared with us. This is not Dave's text; it's a text, of course, that we took from somewhere. That it almost becomes nonsensical to even discuss. The assumptions underlying our presuppositions are so ridiculous that we need to step away from it and reevaluate. We need to go back to first principles again and look at the world, right? We some things we know to be true. Okay, we can figure them out, and other things we just made up because we just running so fast and we coming up with all these wonderful ideas, but they don't fit. Just make up some more shop, and we have given too much. And it's going to sound bad. We've given too much power to the theoretical scientists, to the mathematical scientists. Okay, math is good at describing something, but let me give you a simple example.
No one's found any strings, Mickey.
No, yeah, but 1 + 1 is 2. Am I right?
So far.
No, but in a biological system, that's absolutely not true. If you take a male and a female, you might end up with 3, or 4, or 10. What I mean by that is this: if you got one thing and you add another thing to it, you get 2 things. But if a man, gets together with a woman, the result is not 2 people. The result could be 3, 4, 5, or 6 people if they have children. And that's where mathematics breaks down when it comes to describing things that are non-static. If you describe a non-static system, math no longer works. And when I say non-static, I mean a system that might act in a chaotic manner, in a rational manner, but in a manner that is non-static. Mathematics is very good at describing static systems. It really is. All right. But as soon as and the universe is anything but static. And that's the problem here, right? I mean, we have come to a point now where our fundamental branches of physics no longer work out. Quantum mechanics is completely incompatible with the theory of relativity. Completely incompatible. Doesn't work. And you know what the funny thing is? You heard of I need to explain this. The theorem of Pythagoras. A squared plus b squared equals c squared. The right angle triangle. We've all done it in school, I'm sure, right? So the area above one side equals the combined, the product of the areas of the other sides, right? We're all familiar with that. Now, we think Pythagoras invented that, okay? 2,000 years ago, 2,500 years ago.
That's right.
They found a cuneiform tablet dating back about 5,000 years, where they still call it that, Pythagorean formulas or theorems were used to very prosaically determine the area of a farm purchase. So there's a clay tablet that was found, and it was a subdivision, and someone had clearly wanted to sell it or whatever, and they wanted to see how much money they could get for it, or how big it is, etc. And they were using the right angle triangles formulas to work out the area of the farm.
Wow, that's cool.
Now, what that says is a couple of things. Number one, it was in existence several thousand years before Pythagoras. And I don't want to take anything away from him here, right? And 2, it was such a trivial thing. It was used in the calculation of a land sale. So it wasn't like this. It wasn't like this amazing mathematical breakthrough that it was on this clay tablet. No, this was a working man's clay tablet, where he tried to work out how many shekels will I get for my land? Oh, not shekels, whatever currency they had then, right?
Yeah, that's right.
But this is the point, and this is the same thing. We think we've come up with all this stuff and we know it all, we've named it, only to find out that we don't know anything, right? So Pythagoras just rediscovered potentially, or maybe just published in Greece for the first time, a principle that had been known for a long time indeed. I mean, for crying out loud, the Indian Vedas talk about the atom, okay?
Yeah, that's right.
There's even talk about quantum mechanics in Buddhist teachings. So none of this is new. And we, I mean, when I found this text, I read it through, and I have to be honest with you, I wasn't any smarter once I finished reading it, and no matter how many times I read it, there's so many assumptions and so many suppositions and so many things like dark energy or even dark matter that we don't even know are in existence, that, let's say they don't exist. This whole thing just falls apart. It falls apart completely. Now, some of the things that are predicted by relativity, as well as by quantum mechanics, mathematically predicted, have come true. Absolutely. Unequivocally true. Okay? Mathematics came first, and then tests have shown it to be true. That's why we know that quantum mechanics actually works. Okay? And similarly with relativity. We've done, Einstein had a few predictions. He did, like he formulated some things, and in experimental studies since then, they have shown to be true. Okay. Similarly, though, some things have not, and I come back to quantum entanglement or even quantum decoherence, which are completely inexplicable with our rational mathematical minds. It is truly fascinating to me that this is where we are. We are not much further along from the time when we used to club each other over the head and drag each other into each other's caves. But we think we are. Look at me, we're so good looking at, you're doing wonderful things. And is mathematics useful? Absolutely. I mean, they had to invent a whole new branch of mathematics, or go back to an old branch of mathematics, really, to calculate the re-entry angles for our returning spacecraft, for example, right? These African American women were at the forefront of that. And the truth is, math is extremely useful, right? Up to a point. After that, you really have to go into the lab or somewhere and experiment. You have to do things to test your theories, to test your math. Okay? Because an equation might say one thing, but in reality, oh, whoops, maybe I dug wrong. Yeah. I don't self-proclaim anything. Sorry, Phoenix in the chat room, I don't know, he's been there for like a minute now.
Yeah.
It proclaims that we are rational. I do believe I'm a rational human being, absolutely, 100%. But I also understand that we are bigger than the sum of our parts. So I don't believe we are flesh robots. I think we are four-dimensional representations of a high-dimensional entity. That's who we are. We are a four-dimensional shadow. That's what we are in this particular reality. So I don't know. You can hate me for that if you like. It's fine by me. That's
do what you want. That's right.
That shall be all of the law. Do as you will. Alistair Crowley said this. That shall be all of the law. Do as thou wilt. That shall be all of the law.
Hey Mackie, did you see the thing I posted? And I
many things.
I know.
I want to say yes.
All right. Well, that's good. That's a good start. I said, a society is strong when all conversations can be had.
Yes. I saw that.
Yeah.
I completely agree.
Yeah.
And more importantly, in fact, following on from that very true statement, just because I disagree with you doesn't mean I hate you.
That's right.
We are rational human beings. See, the thing is this: we can make choices that other creatures cannot make. We can run into a house to save a cat. Okay, we can make that choice as a person. So I give my life for a cat. Now, it doesn't help your species. It doesn't help you. It just helps the cat, right? Or you can do it for painting. Maybe you think your life is worth sacrificing for a masterpiece.
Yeah.
So we have that choice, and we're not just driven by instinct. Is my point here. So when we discourse, when we discuss, when we talk about new information or old information, and we look at it a new way, whatever it might be, and you don't agree with me and I don't agree with you, that's okay. That's perfectly all right. We don't all have to bash each other over the head if we don't agree with each other. That's not what this is about. If we can make a good argument, Dave and I, with each other and maybe with you, maybe we can expand your mind a little. Maybe you can expand our minds a little. I've learned a lot from the chat room, for example. I've learned a lot from the research I've done.
Yeah.
Okay? It's really important to keep an open mind. It really is. And it's a sign of great maturity to be able to say I'm wrong. Okay?
Yeah, well, I keep my mind open for all new information. I mean, I call it constant triage.
Yes, it is.
And I think that's where we should be. We should all be there.
Yeah.
We should never close the textbook. We should never just keep researching, know what's going on.
Yeah, and take all the information into consideration.
Mm-hmm.
Not just the information that is allowed or acceptable or vetted. Take all of the information, including what we now call the supernatural.
There's a message for everybody. Include the supernatural. Hey, this is David Mackey's Shiny Side Out. It's the end of the second hour. Coming up next is Jer Bear's wonderful show, After Hours, to carry you on even further to dawn. So there you go. We'll see you next week, and take care, everyone.